So now let's talk about how to do these problems. What you need to imagine is we have an equation for some ball or some arch that's going to be graphed. So in this case, we'll use y is equal to negative 4.9 t squared plus 20t plus 1. And this underlined thing that we have here is what you're actually going to put in for the y value of the table that you create, so you can see what the points look like on your graph. Now, once you've got those points loaded up on the graph, sometimes they don't show up on the graph. So what you need to do is you're going to need to basically zoom out so you can see where the points increase. Okay? And then later on, you can also just add the line y equals negative 4.9 t squared plus 20t plus 1. And that will allow us to get our vertex, okay? Or our axis of symmetry, or the length of the arch, or the time it takes for the ball to drop, okay? So it's not as hard as you think. You just need to be able to graph the points. Now take, for example, this next problem here. So imagine I've drawn that graph that we were talking about before. I'll draw it. Now, for a ball that's moving through space, we always start with time is 0 and everything goes on from there. In this case, we'd start at the y-axis and go across. But if it's an arch, we're going to see where the arch goes from right to left. Okay? And in all cases, we're always going to be looking at the vertex, and the vertex will also give us our axis of symmetry. Okay? Now, the distance moving across from left to right will always give us either the time it takes for something to fall or the distance it takes for an arch.